All right, so one more again. So we're talking today, introduction to electric fields. And for me as a student kind of starting out, electric fields are complicated because we're going to draw an electric field, and it's going to kind of seem like there's something there, like a substance almost. Okay. However, to start off talking about electric fields, I want to reflect back on something that we've already covered, and that would be gravitational fields. Okay, so let's say I have a planet. It's a nice round planet. And whatever. And let's say I have an object right here. And the object's not in motion, it's just sitting there. In general, guys, which direction is that object going to go? It's going to go toward the planet, right? Okay. And let's say I'm drawing a force vector. Okay. If I have an object that's closer to the planet, the force vector would be it'd be longer, right? Because it would have a larger force. If it was farther away, it'd be shorter. Okay, but that's not really pointing in the right direction. But what we should notice, guys, is no matter where I put an object, we should see a general trend of vectors in toward the planet, right? That general trend of vectors is what we would call the gravitational field. Okay, so it's just the field of forces for any object that's in the presence of that gravitational field, right? I mean, you can't touch a gravitational field. It's just that's almost like a collection of numbers, right? Okay, so an electric field and a gravitational field always looks like that, pretty much, straight in. Okay, an electric field is going to be a similar concept. Okay, and so an electrical field, guys, if there's no physical object, okay, you can't touch an electrical field. Okay, it's just a collection of vectors or a collection of forces on charged objects. Okay, the exact same idea as a gravitational field. So, kind of think of it from the perspective, I have a positively charged object. Well, this positively charged object is going to go this way. Here it's going to go this way. Here it's going to go this way. Here it's going to go this way. So I draw out the electric field surrounding a charged object. And electric fields from two objects can kind of interact with each other. Okay, so here I have a picture. It's two different charged objects. And that would be the electric field between a positively charged and a negatively charged object. Alright, so what that electric field is showing me, and the same, back with the gravity, add some lines pointing in. Okay, these lines are showing me directions of forces. Okay, so as you change position, the direction of the force there is changing because I have two different objects now. If it's just one object, it'll all be straight lines. Okay, but two objects, I'm starting to have some curves. Huh? Huh? Okay. So an electric field, guys, is going to be caused by anything that has charge. Okay, so any object that has charge, and when I say charge, I mean net charge. No, I mean, I don't just mean, oh, this object has an electron on it, so it must be charged. Okay, I mean an object that has a net charge. Okay, and so since charged objects exert forces on each other, then any charged object has a field of forces surrounding it. That's kind of redundant to what I've already said. I don't know why I put that in there. And uncharged objects, guys, are going to be unaffected by electric fields, except for in one respect. Okay, an electric field can induce a charge in an object. Okay, so that I could have an uncharged object that becomes charged because of an electric field. So at that point, it could experience force. So essentially, what we're going to be doing today, you saw that drawing a second ago of the three-dimensional field lines. We're just going to be learning how to draw out electric fields. What should they look like for different combinations of charges in different places. And to draw those out, guys, we're going to use something called an electric field line. Okay, and an electric field line is kind of a close approximation. We just draw lots of them, and by drawing lots of them, we get a general trend of what we should expect in terms of force. An electric field line does have arrows, and it will point in the direction of positive charge motion. Okay, so if I'm drawing electric field lines from charges, they should always point away from positive charges, because a positive moves away from a positive, and they should always point toward negative charges. Okay, so in terms of electric field lines, for a positive charge, I'd see the one on the left, and for a negative charge, I'd see the one on the right. And that's if I only have one charge. Okay, the electric field lines do indicate the strength of the electric field as well. Okay, and the way that it indicates the strength is by the density of the lines. As the lines get closer and closer, then that indicates that the field is getting stronger. Okay, so as you're moving away from the charge, far away, they're far apart. Moving close to the charge, close together. Yeah? No, I think. So far, so good. I mean, because stuff's about to get interesting, so we better. We good? Okay, with drawing these electric field lines, they're very simple to draw, but it's kind of like an art. You know how, like if you go into art class, learning how to shade things to make them look three-dimensional, it's kind of hard to explain how to do that. It's just as you do it more and more and more, you get better at it. Okay, it's going to be the same kind of thing with drawing electric field lines. As we practice more and more, we're going to get better at it. But the first couple are going to seem a little shaky. Okay. So these are the three examples I'm going to do. I'm going to give you an opportunity to copy those, and then I'm going to switch over to the document camera and work them out. We good? Got him? What color? Green. Yeah, y'all can be more specific now. I have lots of colors. That green. She said green. Okay, so let's start off with this one here. I have, and I'm just going to zoom in a little bit. All right, I have a positive and a negative charge. Okay, so let's say I took a positive test charge, and the way we draw this is by using test charges. I took a positive test charge and I put it there. And we're just going to place several test charges to get a general feel. Okay, what I should see, guys, is from this charge, I get a force away, right? So kind of a general away. From this one, I get a little force in this direction, pulling toward. Over here, so the net, would be kind of in this direction here. Over here, if I put a test charge, I'm going to see a very large force pulling toward, and a small force pushing away from that one. Okay, so what we see is net in that direction.
Both test charges are positive?
Test charge is always positive. Do you see a general trend of curving around here? You see that? How we're starting here, curving around, curving toward that? I mean, if I put another one right here, this one's going to push away, this one's going to push in this direction, and so I get there, curving around. So the electric field line is going to curve through here and point toward the negative. Between the two charges, there's not really much debate. I mean, it's going to leave that positive and go to the negative, right? So between the charges, I have a straight line. On this side of the positive, I mean, it's always closer to the positive than it is to the negative, and so it's always going to leave the positive. On the other side of the negative, it's closer to the negative, so it doesn't really matter what the positive, it doesn't really matter about this positive. It's going to go straight toward that negative. What now? If I put a positive charge, always using a positive test charge, right, toward the negative. Okay. Now up on this, on the top side, the exact same trend I'm going to see. Okay, so I'm going to see a curve along the top as well. If we continue that trend, guys, essentially, you want to kind of, once you get a general trend, it's easy to kind of fill in. And what we should see, guys, is something like that. Yeah, I know I kind of skipped a lot there. Y'all follow that? I start with a curve, bigger curve, bigger curve, big, and getting flat. Starts to go in the other direction. Big curve, big curve, big curve, small curve, flat.
So you're allowed to put dots wherever you want to?
Yes.
But then wouldn't that alter, would mine and our lines be different because he might put a dot here and I might put it up there?
Your lines are not going to be exactly the same as mine. What this is we're drawing general trends of force. Okay, so let's test this and see. All right, I want a positive and a negative. Okay, and what you should see, guys, is, let's move this to be right on here. Okay, between the positive, we're going straight toward the negative. We're seeing an arrow coming into the negative here, leaving the positive. You see this curving trend here. Okay, and then kind of here, kind of curving out, not really so much curving around. Okay, and so the arrows I've drawn are just very general trends of what we're seeing there. Okay. All right, let's try the next one.
If you have a certain number of dots, can that on there?
I'm not going to put that. That's the last time I'm going to put dots. I'm just going to do lines from now on.
Okay.
Because you could do what color?
Saffron.
What is sapphire? Blue? Is that sapphire enough?
That's nothing like that. Sapphire is like the color of the box behind the mug.
It's like what? Yeah.
See the box that's behind the mug or whatever?
Yeah.
This?
The mug?
Yeah. Behind the mug.
I don't. Yeah, we'll go with oranges then because I don't have sapphire.
So you had everything up
Yeah.
there.
Well, try again. Okay.
Don't forget what colors.
I appreciate your suggestions. Okay. So I have two positive charges here. Notice I have two different charges. Kind of, it's almost like those electric field lines. They connect. Okay. So when you see two opposite charges, you're going to see them connecting. Okay. With two opposite charges, you're not going to see that. Okay. The lines are not going to connect because it's not going to go from one charge to the other one. They're either going to. When now? When it's the opposite charges, they'll connect. When it's the same charge, they won't connect. Okay, sorry about that. All right, so let's say I have a test charge here. Okay, it's going to get pushed really strongly away from this one, but this one's going to push it away some too. Okay, so what we see is really close to this one, it's going to go away, straight away. But as it moves toward this one, what we see is kind of a curving up. Because now, as it moves toward this one's going to force it away as well. So, curve up. Same thing over here. Curve up. Curve up. Curve up. Or curve down.
And these test charges would never repel themselves, right? Like they wouldn't.
These aren't test charges.
Well, I mean, I guess the general.
Yeah. We're assuming they're stationary, but they don't have to be. All we're doing, I mean, that we're taking snippet in time. Here's the electric field. Okay. All right. From here, from this point, it wants to move up and away, right? But this one's also pushing it in this direction, so we can see that continuing trend. From this position, I mean, they're both pushing it away, so it goes straight on the sides. Okay, and then just kind of fill in.
Is there like you have to draw all the lines? Like you have 1, 2, 3, 4, 5.
You get you'll get a feeling for where the lines are important, and I don't know how to tell you something other than that, but
More is better.
more is better. Mm-hmm.
So why is it that the general trend would be a curve?
Mm-hmm.
Why would it be like? Let's say we did use test charges.
Mm-hmm.
And let's say that like we put a test charge. I don't know. You see the vertical line on either side of them. What if you like put a test charge somewhere along that line? Like, nope. I'm not going to go along line. Sorry. Yeah. Now if you go one line up, let's see put a test charge like there. Why would the general trend be for it to curve and not for it to repel?
Okay. From this position right here, there is a very strong force in this direction because of this one, but there's not as strong of a force in this direction because of that one. So it's really getting overpowered. But as I move away from this one, the distance between the two of them is starting to become more equidistant. Okay, so this one isn't overpowering this one as much when I'm here. So what we see is it's starting, this one, I mean, you see how this one's really winning and it's going up. Huh?
Okay, that one's also repelling it very
Yeah. And so as it goes over here, this one's not losing as much, and so it starts to curve. But keep in mind, guys, what we're seeing right here is not the path of the particle. This isn't motion. This is a line representing the forces, where the forces would be on the particle. So if I were right here, if I have a charge, if I put a test charge right there, then it would be forced in a line that's tangent to that line right there. It'd be forced in that direction. If I have a test charge right here, it's not going to follow that path. It's going to be forced in this direction because that's tangent to that curve right there. What now? If it's completely stationary, then it would follow the path. But if it already has some velocity, then it may or may not follow that path. And also depends how much charge does it have on it, how much mass does it have. I mean, there's a lot more involved in it than just that.
So these aren't actual paths; these are just the forces that are being.
This is a line of the forces that are being exerted. All right. So if I take this, take that off, replace it with a positive. What we should see, guys, is a upward curve here. Let's do it right here. Okay, you see that kind of almost like a tangent. Okay, and so each point there it's showing like almost kind of treat each area there as a test charge. Okay, and so it's showing me that that kind of trend there. Is that okay? Those okay? So it's a little bit more difficult when we have 3, but fret not. I'm going to show you 3. What color? Huh? Light purple. I have light purple. This one? That's pink. Hot pink. Okay, so I know from the perspective of the positive charge and wants to leave the positive charge. Okay, are there any points? All right, when it leaves the positive charge, if it goes straight out, it's going to want to be attracted to these negatives as well. Okay. However, if it's right between the negatives, then what we should see is they should cancel each other out. Okay, so we should see a straight line here. And I didn't draw that perfectly, but you get the feeling there. Okay, so straight line here because these would be canceling. The negatives, the effect of the negatives would be canceled. I mean, they're going to pull it back some. However, they're not going to move it left or right any because they're canceling. Okay, if it goes in this direction any, then it's going to curve around to this negative. Okay, in the other direction, same thing. Okay, from these negatives, since they're like, they're going to have that kind of repulsion thing. Oh, other way. Sorry. Okay, so you see that? Here's the attraction that I saw between unlike charges, and here's the repulsion that I saw between like charges. See that?
I don't get how positive charge.
And this should be pointing in.
Opposite way.
But no.
What you did wrong again?
I'm sorry, I put my arrows in the wrong place. Yeah, the arrows always point toward the negative.
I don't get how that's a straight line on the positive charge.
Because the negatives cancel each other out.
Okay, the negatives do pull in this direction. Okay, but in order for it to be a curve, this one would need to pull more.
No, not this.
Huh? This straight line.
Yeah.
Yeah, he's talking
Yeah.
about.
So, in order for it to curve this way, this one would need to pull more. In order for it to curve this way, this one needs to pull more, but it's directly in between them. So
why-
these aren't going to pull it this way or that way. It's just going to go straight away from that positive.
So then why about the ones that are curved towards it? Why wouldn't it just go straight?
Why wouldn't it just go like that?
No, like straight in between them.
Like between these two?
Yeah.
Because it's also being attracted to this negative.
I know, and I'm saying why wouldn't it just like be not parallel, but on the same line as the one that's going opposite? Why wouldn't there be like a diagonal line? No.
Can't there be one of those?
Yeah, like that.
There is. You don't see that? You see that line right there?
You just
I didn't draw it in, but yeah.
You just
it
did right there.
So it does do it on the other side. Then what are those curved ones right there that you drew with the purple marker?
The curved ones that I drew right here.
They're close.
Yeah, those ones.
They're closer ones.
Okay, look, when it's right here, it's just thinking, get me away from this positive, right? And so it's going away from this positive. But as it starts to get toward these negatives, it's like, okay, it's going to go towards a negative. And so if it's exactly in the middle, actually what we would see was simple harmonic motion. It would come away, but then it would be like, oh man, some electrons come back. Oh dang, a proton. We'd see.
So why did you draw that?
Huh?
We don't know that yet. Don't even touch
Not
it.
every single one.
Yeah, you can't draw every single line, but
Nobody wants to see a bipolar.
Okay, it just kind of confused.
I'm sorry.
I would have done a straight line the other direction.
There'd be a straight line on this one too.
Yeah, that was like
There should be a straight line on that one.
Well, there's no charges over there.
Huh? Yeah, you're right.
Correct, he's wrong.
You're right.
I don't know. So if I would have drawn a straight line and didn't do those two curves from the positive, would you have counted off?
You. Okay, here's in terms on a problems quiz. I realize that you're not going to be able to draw every single line that I draw, and so generally the way I do these on a problems quiz is I'll draw one and I'll say, is it right? And if it's wrong, fix it. Okay.
And if I fix it and I like erase those two lines and put my diagonal line or my straight lines and be like,
I wouldn't understand why you would erase it. Erasing the diagonal lines would be wrong, but
Adding more lines would be.
all right. Is that
We'll probably just get easier to practice with this.
clear as mud?
about.
Okay, let's we can look at that one through the software. Hopefully. All right, we needed a positive and two negatives, right? All right, so we see straight away from the positive. This one actually curves a little bit. I mean, you can manipulate it a little bit to get it to go to have it a straight line, but what we see is straight away from here, that kind of splitting in between them. There's some crazy stuff going on here. This is just coming in and then a curve in right there, and so that's that. This is that second line we saw, the curving in toward the electron, curving in toward the negative charge, and then that curving in there as well. So that matches up with what we said. All right, we good? How about I give you all a few to practice? That might be beneficial. All right, try those three, guys.
Will this have any harmonic motion? The emotion on number one?
Yeah, actually, if you put a positive test charge, and it went directly between those two negatives, it would.
Okay.
But you don't have to draw that in, but no. Side to side.
No,
Up and down.
because neither one of the negatives would make it go towards. either electron or I agree. I completely agree.
The first one.
Let's see.
It's pretty easy.
We might need some help.
Do arrows get pointed to the positive?
Remember, the arrows indicate positive charge, so they'll point away from positive. Arrows indicate what the positive would do.
Is there harmonic motion on number 2? Because like, say if one was right between the two positive, so would it go straight to the negative, or would it like curve out or something? Say it was like right between the two positives.
Right, but you could put a straight line right between the two positives toward the negative. You could do that.
Oh, because they cancel
That would be correct.
Yeah.
Yes.
I wouldn't traditionally draw that in, but it's not. I mean, I drew it in on this one. To me, it makes it more difficult to draw that in.
Yeah, because
It makes it.
Because when the two positives actually repel
Mm,
more than the electron would attract.
yes.
So then there would be no straight line.
Yeah. So there shouldn't be a straight line. So ignore my straight line.
I don't even have those on a memory.
Okay.
I know I'm good at this. I just can see it.
So that positive on the right isn't compared to the positive on the left. So you should get this only ones that you've drawn out in the next on the problem space.
Yeah,
And
you
I
should
know-
allow us to see our notes and problems with.
I don't need my notes and stuff, but
Can I come over here and check?
no. Yeah.
Kind of.
Did you get everything? Isn't it supposed to?
Okay. On number 2, ignore that middle line. We've decided that doesn't need to be there. Mhm.
For on number 2, like, you have 2 lines coming from like the negative and positive line, but I just only do 1.
Wait, what now?
You have like,
Wait, show me.
see how you have 2 lines, and I just drew 1. Was it like necessary for me to draw 1?
I just drew it, but I mean, drawing in too many is not going to hurt you until it gets a jumbled pass.
I need, kings.
You're not going to see in the problem you have right here. You're not really.
Going to see a general trend.
You're not going to see as much as that because as you move farther away, the two negatives are going to overpower the negative. That's the reason I didn't draw as many coming from infinity. Yeah. At some point, they kind of cancel.
Okay, why doesn't that get repelled by that? Why isn't it like?
Because it's closer to the electron than the proton. So the electron has a greater amount of influence than the proton does.
I'll hear the attitude.
So what if it's like right above the electron?
I don't think those were.
Yeah.
I don't think those were.
We're talking about it. It really depends on the distance. Close in, it's going to come to the electron. Out here, these two protons are going to repel.
It's not working. That's why I was thinking like it was the.
No, you actually don't need to include that as an accident.
So now it's on the return.
How long do you have to return?
I feel like push it in the middle. That did sound like
Okay, so a few comments, guys. Here, the reason why I did not draw in any lines coming in from infinity here is because at a certain point, let's say I have a test charge right here. I have a force going away from this proton, a force going away from that proton, a force coming in from that electron. Really, these protons are going to overpower that electron at some point.
So that's also the same reason why we would not put that straight line on number 2.
Yes, that's the reason why you don't put the straight line in on number 2, because these protons are going to be stronger than that electron. Okay, so it's not going to draw it into the electron because the protons are going to win there.
they just like stop at a certain point and just go back down.
If it was coming in,
Maybe you just wouldn't do it from infinity because of those.
No,
if it was so,
But in a hypothetical situation, if it was like to go between those two, would it stop and then just be repelled back down?
if it was going straight in between, it would come in, slow down, slow down, slow down, slow down, and then go back.
Yeah, okay, that's what I'm
And if it had enough momentum, it could break past. And if it had enough momentum, it could break past those and then be attracted to the electron, or the negative charge, not necessarily an electron, but remember these are diagramming force, not motion.
good.
All right. Any questions, or is that we good on the diagrams, guys? All right, grab a partner, talk it out.
No. Can we talk?
Y'all do that every day?
Do you think?
How I've never seen it.
From the cloud to the ground, a different.
Alright, draw and approximate.
Yeah, because the ground is positive. Away? No, it's. That's gonna get me uncomfortable. That the way the arrow is.
Okay, so it's positive.
So, this positive is the top positive or the bottom?
The bottom of the cloud is negative and the ground is positive.
Sometimes we say they flip around.
To remember, think that a positive has two lines, so you make an arrow, and a negative has one line.
I don't understand how.
No, it's the opposite.
Yeah, it's the opposite. I was like, that's
I came up with that off the top of my head, it didn't work.
Remember that when.
Remember that rule, and then remember it's the opposite of that rule.
The negative is a particle.
You gotta draw the crap.
Uncharged
Okay, yeah,
object.
but here's
It could.
the target.
Not ionized, but
I'm drawing a cloud.
polarized.
Or if it could cause us, but actually the electric field is flat and flat. It's gonna be straight.
But no cloud is flat.
Pretty, you know.
It's
It's pretty flat.
So all of them's up top.
Everybody knows you draw a cloud, just one straight line.
Everybody
knows
it's too loud.
If you write on there what page numbers are, so I can.
Oh yeah.
See, if you know it, you know. If you don't know it, you know I don't know it.
And then what if you're on a hill? That'll cause some fails.
And actually, we're gonna get there. That's gonna be really interesting. What's gonna happen?
I'm such a thinker.
And then what if you're on a hill?
So the
So watch your shave your eyebrows, so you can eyelash.
Except my face. I remember I shaved my head.
okay, let's talk it out, guys. Do charged particles follow the electric field lines exactly when they're traveling? Not necessarily. They could, but not necessarily. Number 2, what effect do you think an electric field has on an uncharged object?
None, unless it's induced.
None, other than if it induces a charge. Okay, and then for an approximation of an electric field below a thundercloud, if I have the ground and the bottom of a thundercloud, then since I have positive charge down here and negative up here, we're pretty much going to have straight electric field lines upward.
Could it ever switch around? Like, the bottom of the cloud be positive?
Yes.
And it could?
Mm-hmm.
So what kind of thunder strike would that be?
Upwards.
You do sometimes have,
Like downward strike?
you know, sometimes you have,
I thought that was like fake.
These are
I-
the videos say.
yeah.
Not necessarily that
Yeah.
situation.
Oh, okay.
but that's possible. And actually, sometimes, if you think about it, remember we said that we have the thundercloud, and the bottom of the thundercloud's negative, but the top of the thundercloud's positive. And so, since we have this kind of evacuated region, we'll actually have negative charge on the outside. So while we have some thunder, some lightning, going down that way, we'll actually have some that'll go.
Inside of the cloud?
But we have some that'll do that as well.
And you have it going inside the cloud, like some kind of little lightning strike inside the cloud?
Yeah.
Is that possible?
Mhm.
Oh yeah.
Mhm.
Hey, is there any homework for tonight?
No homework for tonight.